Hey, we're back. This is part B of the ultrasound non-destructive testing lab. The big picture for this lab is we're going to be determining material properties of a couple different samples. Here we have a chunk of brass, a chunk of aluminum, might have you do steel too. We'll read the lab handout to make sure of everything you need to do. So this is one of the applications of ultrasound. You can determine material properties. There's a speed of sound, a longitudinal speed of sound, and there's a transverse speed of sound in solids. And if you determine those, you can determine the material properties, like Poisson's ratio. We're going to measure the speed of sound for longitudinal waves and for transverse waves. Remember from lecture, both those waves are propagating this way and coming back. It's just that the longitudinal wave, so say you had a slinky that ran this distance, you were exciting it like this, then you get those pulses, the compression and the rarefaction going this way. With the shear or transverse, it's more like you took that slinky and shook it. So the oscillations are this way, but the propagation is still like this. So both cases, sound's propagating through and coming back up. Let's talk a little bit about the transducers. So here, because the bigger size, and we're not trying to, we don't really need spatial resolution, we're using these bigger in size transducers. You can see the 0.5 there to the right. So the other ones are 0.25 inch. These are 0.5 inch. And then you'll notice to the left of that, there's the 2.25. So these operate at a lower frequency. Note right here, you see that V106? There's nothing etched in to the right of that. Over here, there's the V154. And to the right of that, an S is etched in. And if you went and looked up the 154 and the 106, you'd find out that the 106 is longitudinal and the 154 is the shear or transverse. But you wouldn't know that just from looking at this, so we've etched the S on there. So when you're doing the shear portion, use the one with the S. When you're doing the longitudinal, use the one without the S. And then also different couplets. So like in part A, we'll use the glycerin for the longitudinal, and for the shear, we'll use an adhesive. Just so I don't forget, when you're done, you make sure you clean this off of both the transducer and your sample, and remember that this is water soluble. You just get a paper towel with a little bit of water on it and rub it off. Okay, now how we wire this up. This one we don't need a power supply, we just plug it in, and there is a switch back here, so turn that on. And then here also we have a sink, and you can see that, a sink and a signal. There's a high pass filter back there too. Having that high pass filter on might clean up the signal a little. That's one of the things you might want to try adjusting. But what you want to do is take your sink and your signal and run those to your oscilloscope. I believe I have the sink in channel 2 and the signal in channel 1. Go ahead and fire that up. We'll come back to that. So there are a number of settings on here, and some of them you might just need to play with to find out what's best, but there are certain things that we definitely want to have set. So this operates in two different modes. There's a send and receive mode. So when we have it up here, that means you're using one transducer to send and receive the pulse. And when you do that, you just want to plug one transducer into this one here with the transceive and receive. if you flip this down, you could use one transceiver to send and another to receive. But we're not doing that. So have that up here. Likely want to have the gain on full, so both this switch and this switch. So these two over here, these you probably want to mess with a little more to find out what works best. I think that's, what's that, pulse repetition frequency or something like that. When you have a thinner sample, say like an inch, relatively thinner, having this near its max would be a good choice. And then as it increases in thickness, you might want to back that off some. So turn that down a little. So this sample here is about 1.5 inches. This one's about 3 inches. You'll want to measure those more carefully with the caliper when you do your calculations. But maybe back that off a little bit and try adjusting it to see what kind of signal you get. So let's look at that. So I have a shear transducer on there. I will try one-handed to put some of this adhesive couplant on there without making a mess of myself and the lab. Just put a little bit of that on here. So it's probably too much. If you have two hands, I hope you do a better job than me. But that's more than enough there. So let's take this, and maybe this one will stick a little better than what we did in part A, because it is an adhesive. Let's just, so again, make sure we're using the side without any writing. These come with caps too that I've taken off. So plop that down on there, press it down, good. That should stick pretty well. And let's come up here. So we're seeing some stuff there. Let's auto set, always a good idea to start out. And let's bring our channel. So the auto set was over here. Press that. Auto sets. Channel 1. Let's bring that down close to the middle. Let's bring our channel 2 up. I like to see those channel 2 right on top of it. And then we can probably zoom in vertically, see a little more amplitude. It is jumping around quite a bit right now, but let's just zoom in on one of these. It cleaned up a little bit when I zoomed in. Can zoom in vertically a little. So likely if I'm going to pull off this transducer, we should see a bunch of those disappear. Yeah, so there they disappeared. So essentially what we're going to want to do is set these cursors to measure. So come over here, press measure, and then rotate this knob until we get a cursor. See my cursor's moving over. Let's put it right on that pulse. You know, let's even zoom in a little bit better. There we go. So this is zoom in horizontally. Let's take that cursor over and put it there. And then when I hit select, let's bring this other one over here, put it right there. And let's turn the indicators off. I should clear it up more. So we're seeing 48 microseconds. You're going to want to take that and use the caliper to measure the thickness of that. Remember, that's the time it takes for the sound to pass through once and come back up. So using that information, we're going to want to find out what the speed of sound is. The longitudinal speed of sound is. Oh, I'm sorry, not longitudinal. Now we're doing the shear. So this would be the shear. We will determine the shear speed of sound. And go online, like Engineer's Toolbox, something like that, and compare the value you calculate to a published number for the transverse or shear speed of sound. You likely shouldn't get exactly the same thing, but you should get something pretty close. That's a good check to make sure you're doing things right, but then use the value that you actually calculate in the equation to find the material properties. And also, don't forget to do the longitudinal with the glycerin couplant. It'll roughly be the same procedure, just different material, different couplant, different transducer, different speed of sound. You should be able to find both the longitudinal and the shear or transverse speed of sound through those materials in something like Engineer's Toolbox. That's it. See you in lab.